Ed says we live on a little known planet. So the species data, where's it coming from? And how are you gathering that data? How are you analyzing that data, processing that data? And what is the difference in the approach that you guys are taking at HalfEarth from maybe other approaches that have been taken in the past?
Thank you. Yeah, so what we are doing, what spatial conservation prioritization, that's kind of that larger field that we're talking about here is generally doing is it relies on data collected in the field, some of the very sort of data that Ed has been and still does collect for ants and in his case and other species groups. And many other naturalists out there that he has inspired or that are just going about their work and have been going about their work for the last century. So a lot of data is actually sitting in museums. It's attached to museum specimen and the coordinates that are sitting with them. So don't think about these specimens just as dead pieces in a museum. They're actually convey important information about where they came from and provide a record. And nowadays, there's a lot of citizen science activities. Some of you may be citizen scientists yourself and checking in species that you see through some app and contributing them. And then there are experts that ultimately synthesize that information and draw maps that you may be familiar with from field guides. If you ever sort of had a field guide in your hands for birds or plants, whatever it may be, there's this little map. And I was just, talking more about how we do this and how we develop the evidence base, if you will, and this draws on efforts, contributions of thousands and tens of thousands of scientists and citizen scientists over the last centuries, and particularly in recent days, people that are compiling observations. We are, if you will, the synthesizers. We and others out there, biogeographers, conservation biogeography, we try to bring that together, information together, and we in particular at the HalfEarth project, in liaison with a project called Map of Life that's hosted here at Yale University. We are developing models that then pull in also remote sensing information from satellites, a whole suite of artificial intelligence or statistical methods to then come up with the best possible characterization of where each single species occurs on the planet. And that's obviously an imperfect science still, and a key effort of ours and of many other scientists in the field of biogeography is to do better and map through these quantitative approaches, linking in remote sensing and other things, more and more of biodiversity and greater detail. So that's, if you will, at the heart or at the base of the HalfEarth map science. Because without this information, you don't know, right, what may be occurring in a particular place and what you may be losing. Now, with this information, for tens of thousands of species, you can do something called a spatial reserve design, or you can apply optimization techniques that use the principle of complementarity to identify the places that are most important for species going forward. So if you were to lose that place or change something in this particular place, a place where any such impact would have greatest repercussions overall. So the hotspots, if you will, of conservation priority. That's what we're identifying through these first single species models, and then through approaches that build on top of that and drive prioritization algorithms.
Would this
and if you allow me to, I can quickly show you the map, the global map that actually shows some of the results, if you will. Cool.
I was going to say, this sounds like a great time to show the map.
Yeah. So if we jump over here, I get to share my screen. One moment. Are you able to see my screen, Rachel?
It says yes, you're all set.
Cool. So I hope the bandwidth is supporting this. So what we're looking at here is the current version of the HalfEarth map. And you can find this at half-earthproject.org/maps. And here is kind of a simplified version, if you will, of the top places for conservation activity going forward for, in this case, terrestrial vertebrates. So that's birds, mammals, amphibians, and reptiles. So tens of thousands of species supported the identification of these places. And I was mentioning Madagascar earlier, and it's really one of the most marvelous places in the world that holds an incredibly large number of unique species that are not found anywhere else. You may all be familiar with the lemurs, but there are many other species groups that chameleons, for example, certain reptiles that you only find in this region, that makes that part of the world a real high priority place for conservation. Or we can go to the Atlantic forest down here, and we can go in and explore this area a bit further and learn about what species are particularly important in this place. So you see through this visualization how certain birds, for example, would be limited to just that region. This brassy-breasted tanager, for example, has a really small global range, and pretty much all of it is restricted to the smaller and smaller parts of the Atlantic forest that have not been yet encroached through agriculture or urbanization. And these are species that don't occur anywhere else in the world. So if you're in this location losing habitats, you're about to lose those species. So in the HalfEarth map, you can see how much of that landscape may already be protected. You see this in the darker green areas, and then which places are already encroached. Sao Paulo, one of the big metropolises, one of the biggest metropolis there is in the world, is together with Rio de Janeiro more and more encroaching on these mountains, on these forests. And thanks to satellite-based monitoring of the Earth's surface that we are bringing to you here in this browser, we were able to see these impacts in greater detail. And in the HalfEarth map research, we are linking these high-resolution pieces up with one another to then identify the places that are most important for future conservation activities. And we can do that not just for a single place or these hotspots that I was pointing out, but we can look at the full global map and identify here in yellow in a continuous color scale from highest to lowest, highest yellow, lowest blue, the top priority places in the world for future conservation activities. So here, pretty much all of Madagascar, bright yellow. Many of these corners of Africa that hold tropical forest, super high priority. Here we were talking about the Atlantic forest in Brazil. Also much of Mexico, and then over in Baja and actually many parts of California, and here for amphibians in particular, southeastern United States holds actually global significance because the species there, a lot of the frogs there, and some of the reptiles only occur there. So the US is in the game here very much. And this is, we're looking at kind of a biogeography, right? The reason why much of the north here is rather blue is because of colder temperatures, past glaciation, leading to relatively few species occurring there. And certainly then the species that occur there often not being geographically very rare. So many species you find in Connecticut, you would also find over much of Canada. So feel free to explore this map and look at some of these fascinating overlays in there with existing protected areas, or indeed with existing human pressures. And there are some parts that we are offering up in great detail. For example, here in South Africa, you can look at some of the very detailed modeling that we're undertaking, and look at those patterns in great detail. So perhaps I should lead back to you, and if there's another question, I can come back to this, and we can drill into some of these places.